and they want you to find theta. Okay? So we know all sides, so you can use cosine law. Okay, so remember we want cos theta, so we start with 232.6 squared equals 221.2 squared plus 221.2 squared minus 2 times 221.2 times 221.2 cos theta. Phew, it's a lot of work. So you'll get here, once you work this out, that cos theta will be 0.447337. Okay, that's if you're not rounding as you go. You shouldn't be. You should be keeping all the numbers in your calculator. And then you take the inverse cos of this number, and you get your angle to be 63.43 degrees. Okay? All right. Now we get an example where it's asking you to use bearings. Okay, so you have to know your directions in order to solve this problem. So the radar operator at an airport, sorry, just a second, locates two planes flying towards the airport. So here's the airport here. They're at the same altitude, so don't picture them up and down from each other. So we're able to just use a two-dimensional triangle because they're at the same altitude. Okay? So one plane is 120 kilometers at a bearing of north 70 degrees east. So here we go north, and then from there we go 70 degrees to the east. So you place your protractor here, and if here's 90, then we go 70 degrees this way, so to 20 in this case, because that's 70 degrees from. So there's the line for the angle I want to use. And I draw a line to show. Here's the plane. We'll call it plane A. Okay, so it went north 70, so this is 70 degrees. Because we went straight north and then 70 degrees to the east, and it's 120 kilometers long. Okay? Then we have, the other is 180 kilometers away on a bearing of south, so we go start with going south, and then 55 degrees east. So here's south, 90, so then 55 would be here at 35. So you go 55 degrees that way, and it's 180 kilometers away. So farther away, so I'm going to kind of go down into my next question. It's not going to be exact here. So here's B, where this is 180 kilometers, and this here is 55 degrees. Okay, so now they want to know how far apart are their planes. So they want to know the length from A to B. That's what they want to know. So, how can we solve this problem? Well, we know two sides of the triangle, 180 and 120. We don't know this, and right now it looks like we don't know any angles on the inside of the triangle. However, we did have these bearings, so we can use these bearings to find out how large this angle is. So if this is 70 degrees, that means to get here, you would add an additional 20 degrees. Since all together this is a right angle, or 90 degrees. And if this was 55 degrees here, then to get the rest of the way, it would be 35 degrees. So this little section is 35, this little section is 20, so all together this angle is 55 degrees, okay? Now, that doesn't have any relation to this 55 degrees, it's coincidence those two are the same, okay? This 55 comes from adding the 20, which is complementary to 70, and the 35, which is complementary to 55. So now we have two side lengths. We have side, angle, side, so we can use the cosine law to find AB. So you should be able to do the rest of it by yourself. You just set up your cosine law with AB being the unknown. So AB squared equals 120 squared plus 180 squared minus 2 times 120 times 180 cos 55 degrees. Okay, so you'll get that AB is equal to 148.4 kilometers. All right, so you need to be able to draw bearings appropriately. All right, one more example, and I'll be honest, this one's a little bit tricky to do in 2 dimensions. Like it is a 3-dimensional question. And so remind me tomorrow in class or next day in class to actually do this 3D with you guys, because it makes a lot more sense when you actually see it 3D. But I've attempted to draw here, and I know it looks so gross because of this, all those smudges. It really annoys me. But I did try my best here to draw this for you. Okay, so this situation, you have a bridge. The bridge is 50 meters tall. So this is here, I'll try to redraw this one here a bit. Here's the height of the bridge. From you guys are like, what am I even looking at right now? Okay, there. All right, so you have a bridge. So start with just drawing a horizontal line and labeling a bridge. Okay, and here's where you have a person looking from the top. Okay, and here's the bottom of the bridge. So that means all of this here is water. Water, 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 water. So this is 50 meters tall. So you can start with just drawing this and this and this, where the height of this is 50. So this is the bottom of the bridge. This is the top of the bridge. Okay? 2 boats are seen at anchor. So this boat's chilling out here, it's A. This boat's chilling out here, it's B. Okay? So draw your little cross here because we're using these bearings again. So one is south 50 degrees west. So you go south and then take a protractor. It makes a better diagram if you use one. I use one. And do 50 degrees out here. Okay? So we don't know how far this is, but you can draw a line here that's a certain length out and make A. There's boat A. Don't worry about the angle of depression yet. The other boat is south, 60 degrees east. So you go south and then measure 60 degrees to the east and draw a line, and there you have boat B. It's chilling there. So they want to know how far apart are the boats. Now they also give you the angle of depression for each one. So the angle of depression is the angle that it makes with the horizon here. So if this is going out towards the horizon, okay, this line, you want to make this line up here parallel to this line down here. So take your ruler, okay, draw yourself this line, take the line that you drew from here down to A, and just move it up so it hits T, and draw another line. Okay, so this line and this line should be parallel. Then connect this dot here. So that creates this Z, okay? That creates a Z pattern. So here is where the angle of depression is, and that you can label that 38 degrees. But now because this is a Z pattern, that means this angle here is 38 degrees as well. Okay, the same thing will happen over here with boat B. Make this parallel to here, and then connect T with B to create another Z pattern where these lines are parallel. So this angle of depression is 35, so this angle here is 35. So really I should label this point here, I'll call it, I don't know, C. So I'm trying to find AB. So notice I know that this is 50, I know that this is 50 degrees, and this is 60 degrees. So actually I do know that all together this gives me 110 degrees. But I don't know the length of CB, I don't know the length of CA, and I don't know any of these angles, and I know it's not isosceles, so I can't do anything else here. So I have to deal with this triangle. So what other information can I find in this triangle, A, B, C? I don't have the side lengths or angles. Is there a way that I can find these side lengths, A to C? Well, check out. This is also a 3D triangle here, and it's actually a right triangle. T to C to A is a right triangle because this is just water, okay? So this here is actually a right triangle. This is going straight down the bridge and then going out to the water. So you have to imagine it actually coming out to the water. So T to C and then out to A is actually a right triangle where T to C is 50 long, and then angle A here is 38 degrees. 38 degrees, because remember we use that angle of depression. And so therefore I can find this length using SOHCAHTOA. So I know the opposite, and I want to know the adjacent, so I can use tan. So tan of 38 degrees equals the opposite, 50, over AC, which is what I want to know. So AC is equal to 50 over tan of 38 degrees. So my AC is equal to about 64. Okay, it rounds up to 64. Okay, I can do the same thing with TCB. Okay, the exact same thing. So I can say that tan of 35 degrees is equal to 50 divided by BC. So solving that, I get that BC is equal to 71.4. Okay, so this is about 64.0, about 71.4. So now I know this length, this angle, so now I can find AB. So I'm going to recreate that triangle just so I'm not confused. So I found that this is 110. I know it doesn't look like 110, but it's 110. I found that this is 71.4. This is 64.0. So now I can find AB using the cosine law. Okay? So you go ahead, you use the cosine law, and you find that AB is equal to 110.94. So the boats are approximately 111 meters apart. Okay, so there's a lot going on in this example. I realize it's difficult, but probably the most difficult part is drawing this diagram. So I will show you in 3D how it looks when you actually do it, and hopefully you're able to see how this diagram was created. But again, it's all about taking a situation and turning it into triangles. Where are the triangles? Are they right triangles? Are they not? What information do I have? What information do I need? And then how do I get that information that I need? So for some of you, you might find this a fun challenge, like a little puzzle. And for others, it might be more frustrating if you have trouble putting descriptions into a visual. So the best way is just to work at it, keep practicing, see me for help, see your friends for help, and just keep learning. So thanks for watching, and I hope you learned lots.